Welcome back. This is week 12 lecture video part 2. We are talking about esters in this video. Week 12, we are learning about carboxylic acids, esters, and amines. In the previous video, week 12 lecture video part 1, you learned about acid-base reactions of carboxylic acids. That's here. The other objective we were focusing on is Fischer esterification and ester hydrolysis. That's what this video will be. Lecture video part 2 will be Fischer esterification, which means forming esters, and then ester hydrolysis, which we'll see means breaking esters back apart. The third video for this week will be focusing on amines. Lecture video part 3 will be on amines. That will be on page 50. We'll see that in the next video. Before we keep going, let me make sure you remind yourself how to identify carboxylic acid, how to identify ester, and what the difference between them is. This is what a carboxylic acid structure looks like. Carbon, of course, makes 4 bonds. 2 of the bonds are a double bond to oxygen. A third bond also bonds to oxygen, so that's a total of 3 bonds to O. The fourth bond on carbon goes to what we call the rest of the molecule. But pay close attention to this oxygen right here. Oxygen needs to make 2 bonds. One of this oxygen's bond is going to that carbon, but it needs 1 more. So if that 1 more bond is an H, that's what makes this a carboxylic acid. So again, if you take a look, you see that carbon is making a total of 3 bonds to O. 3 bonds to O, and that oxygen goes to H. That's carboxylic acid. What's different with ester is what this oxygen here is bonded to. We still have carbon, of course, making a total of 4 bonds. We still have carbon making a total of 3 bonds to O, just like it did here. That oxygen already has 2 bonds. This oxygen needs 2 bonds. One of the bonds is to carbon, as we see, but the other bond on this O, instead of being to an H, as it was for carboxylic acid, it goes to another carbon. It's bonded to another carbon. So this right here is the structure, the basic structure of an ester. Sometimes these will be called carboxylic ester, but there really is no other kind of ester we'll see. So most commonly, they're just called esters. That structure might be abbreviated COOC, just as the carboxylic acid structure might be abbreviated COOH. So this is the difference between carboxylic acid and ester. And as I said, you learned about acid-base reactions of acids in video 1. And in video 2, we will learn how to form esters. What are the reactions that form esters? And then what are the reactions that break the ester back apart? So I will ask you to join me on page 141. Page 141 introduces the reaction of Fischer esterification. And I'll just remind you, this is the reaction that forms esters. The reaction that forms esters, and the reactants are alcohol and carboxylic acid. So if you want to form an ester, you start with an alcohol and a carboxylic acid. So you can read along. This is describing in words what the general reaction looks like. A carboxylic acid plus an alcohol will react to form an ester, and we'll see that the other react. So the first example, I'm going to go through 4 examples. The first example shows acetic acid. You can see that it's a carboxylic acid, so I will remind you of that, carboxylic acid. It's reacting with ethanol. You can see from the name that this is an alcohol. Its name ends in OL, and you can see from the structure, OH bonded to a carbon, that's alcohol. So carboxylic acid plus alcohol, they're going to react. You know from previous reactions that if you see something written above the arrow in the equation, that means that that's a catalyst. So H2SO4 is a catalyst. What you will see happen, and this will happen every single time that a carboxylic acid and alcohol react, is this. The OH on the carboxylic acid and the H on the alcohol combine. So I'm going to draw a box around them like this. You will often hear me say, box out water. Here's why. OH and H, that's two H's and an O, that's water, H2O. It splits out and forms one of the products, here, water. So this H and this OH are this H and this OH. That forms water. So the first thing that I'll always say is box out water. And then the second thing that I'll say is you've just broken, in order to box out water, you've broken this bond and you've broken this bond. You can't have those two bonds pointing into thin air. So what happens is that those two bonds join together to form this new bond. Those two broken bonds join together to form this new bond. So I'll say it the way that I will often be saying it. Box out water and then slide the two pieces together. Everything outside that box does not change. So if it was this structure before, it's still there. If it was OCH2CH3, it still is OCH2CH3, and now they have combined together. That new bond is given a very specific name. It is called a new ester bond. And I hope that you can see why it's called an ester bond, because we have just created an ester functional group. Carbon double bonded to O carbon, right? This is the carboxylic acid functional group, which means this new compound is a carboxylic ester. And I'll put the word carboxylic in parentheses because, as we said a moment ago, carboxylic esters are often just called esters. They don't need the prefix carboxylic because this is the only kind of ester that we'll see. So box out water, slide the two pieces together. That general reaction is called a condensation reaction. We'll be seeing that a bunch. We'll be seeing it nearly every week for the remainder of the term. Condensation in general is when you are able to box out water. If the two reactants specifically were carboxylic acid and alcohol, then the product you get is ester. And in that case, that specific type of condensation is called an esterification reaction, forming an ester. So again, to summarize, that esterification reaction always looks like this. Start with carboxylic acid and alcohol, and you end, your products will be ester plus water. So let's do 3 more examples of forming an ester. Example 1 shows benzoic acid. Let me zoom in just a little bit here. So you can see that benzoic acid is a carboxylic acid. There's the carboxylic acid. I'll remind you of that. Methanol, you can see that that's an alcohol. As soon as you see that you have carboxylic acid and alcohol, then you know what will happen. Box out water, slide the two pieces together. Everything to outside the box does not change. It stays exactly the same. So the bond that was broken here and the bond that was broken here, they slide together to form this new bond. That's a new ester bond. Which means that this structure is a ester, and then of course plus water. So carboxylic acid and alcohol react to form an ester plus water. This example is done for you. The last 2 examples that I would like to do with you, we need to finish them ourselves. So let's see how that would look. I see that this is a carboxylic acid. I see that this is an alcohol. So what will happen is this: box out water, slide the two pieces together. Everything before the box stays the same. It will not change. So I will leave it exactly as it was. CH3, CH2, C, carbon double bond O. So far I've kept it the same. But that bond now, the O is gone, the H is gone, the H is gone. So this bond now connects over to the O. Remember that the OH and H are gone. So C connects over to this O. And now the rest of that molecule also does not change. Keep it exactly as it was. The second product is H2O from the box out water. This bond right here this bond right there is our new ester bond. So we have formed an ester. Carboxylic acid plus alcohol forms ester plus water. I encourage you right now to pause the video and practice example 4 on your own. Identify what you have, alcohol, carboxylic acid, whatever. Box out water to form your products. So pause your video and do that. Now that you're back, let's do it together. Carboxylic acid, there it is going to react with an alcohol. There's the alcohol, and you know what happens. Box out water, slide the two pieces together. Everything outside the box stays the same, so we'll copy it exactly like it was. When we get, so there's the carbon double bond O, we get to here though, and remember the water has been boxed out. O is gone, H is gone, H is gone. So this carbon double bond O will be bonded to this O, and then nothing else on the other side of the box changes either. So the first product is this, the second product is water, and this, of course, is an ester. Right there is the new ester bond. To summarize, Fischer esterification reaction is a specific type of condensation reaction. Esterification is carboxylic acid plus alcohol forming an ester plus water. Before we keep going, I want to point something out that, you might not have noticed or that you might have questions on. And that what I'd like to point out is this. If you wonder, should you box out the OH here with the H here, or should you box out H here and OH here? In terms of the product you get, it doesn't matter. If you chose to box out this H and that OH, you'll get the exact same ester. I have shown it the way that it actually happens. If you study these reactions, you learn that it's always the OH from the carboxylic acid and it's always the H from the alcohol. But you'll get the same structure either way when you're drawing that reaction. All right, so that's how you form an ester. I'm going to flip the page over and we're going to look at what happens, how you would break that ester back apart. To do that, I'm going to draw this arrow this way. And you know what this means. This means it's a reversible reaction. Sure enough, in the examples shown for you, it's always a double arrow, double arrow, double arrow. That means it's a reversible reaction. So we will look right now at what that reverse reaction looks like. Apparently, we can take ester and water and go backwards to get back to the carboxylic acid and alcohol. So let's flip the paper over, see what that looks like. Page 142. Carboxylic esters hydrolysis, what that means is break the ester apart to get back to the carboxylic acid and alcohol. Just running the reaction in reverse. Fischer esterification in reverse is hydrolysis. So what that will look like is, here's our ester. And if you recall, water was the product in the original reaction, so that means it's a reactant here. So what we'll do is we take the ester bond. It's important to be able to identify the ester bond. You know that this is an ester. The ester bond that breaks will always be the one between the carbon and oxygen, the single bond between carbon and oxygen. So a single bond between C and O is the bond that breaks. So the ester bond will break. And then of course we can't have that carbon only making 3 bonds. We can't have that oxygen only making 2 bonds. So water sneaks itself back in. So when that yellow bond breaks, when that ester bond breaks, the carbon needs one more group attached to it. That will be the OH from the water. This oxygen needs one more group attached to it. That'll be the H from the water. How do you know which gets the OH and which gets the H? Because you know that you need to end back up with the carboxylic acid. You know that you need to end back up with an alcohol. That's how you know you don't put the H here. That would end us up with aldehyde. And you don't put OH here because then you would have something that is not even a stable structure. So you will end up with carboxylic acid and alcohol. Let me do example 2 for you together, and then I'm going to ask you to practice example 3 and 4 on your own. So let's look at example 2. I see that this is an ester. The only reaction that we will see for esters is the one we've just looked at. In other words, if you see that you're starting with an ester, the only thing that we will see esters do is hydrolysis, breaking it apart. So if you're breaking it apart, you need water always. This must be a catalyst. H2O is the catalyst, and water is the reactant. So what we have seen is that the ester bond will break. There's the ester bond. Everything on each side of the ester bond stays the same. Oops. Everything stays the same. That ester bond is broken, so I know I can see from that carbon double bond O that this will become the carboxylic acid, and the other piece of it will become the alcohol. So here's the CH3O becomes the alcohol. The other fragment becomes the carboxylic acid. Again, water is a reactant in the hydrolysis direction. In the formation direction that we saw earlier, it's a product, but here it's a reactant. So please pause your video now and practice on example 3, practice on example 4, and then when you come back, we'll do them together. Okay, now that you've had a chance to practice these, let's do them together. I see that this is CO2H. We're not used to seeing something written this way, but this is an ester. I'm going to sneak this over here. Remember that an ester looks like this. But at the beginning of this video, I reminded you that it might be abbreviated like this. And it might even be abbreviated like this. All three of these are abbreviation for ester. So this is an ester. Excuse me, we're reacting with water. And so I know that we will end up with carboxylic acid and ester. Carboxylic acid and alcohol. Here is the COO part here, and this is the ester bond that will break. So what I'm doing right now is unabbreviating this so that you can see it a little bit better. That was abbreviated, so I've unabbreviated it, and then we can see that this is the ester bond that will break, and when it breaks, we will get a carboxylic acid plus an alcohol. That's 5. So the ester reacts with water to make carboxylic acid and alcohol. This one was maybe a little bit trickier because of that abbreviation, and so notice what I did. I unabbreviated it so that we could see it better. How about the one below? This is also an ester. We can see that. The ester bond will break. And when it breaks, we will get carboxylic acid plus alcohol. How do you know which is the carboxylic acid and which is the alcohol? The carbon double bond O will give us the carboxylic acid. And then the rest of it that has just the single bond to O here becomes the alcohol. So again, I didn't change. If there was 1, 2, 3, 4, 5 carbons before, I still have 1, 2, 3, 4, 5 carbons after. You don't change the skeleton on either side of that ester bond. So those are 4 examples for you of ester hydrolysis. And as a reminder, it's just the reverse of ester formation. If you would like additional examples, I have supplemental additional video help on this same topic that you can refer to. Thanks for joining us. We'll see you for video part 3.